Imagine this: a raging winter storm knocks out the grid for days. Your solar panels sit useless under dark skies, but high above, powerful winds howl with untapped energy. While most off-grid enthusiasts fixate solely on solar, wind power stands ready as a powerful ally that many completely overlook. In reality, photovoltaic solar panels make up roughly 90 to 95% of all small-scale, decentralized off-grid energy systems. For most people, alternatives rarely even cross their minds. Yet the physics of wind should never be underestimated. A single cubic yard of air moving at just 20 miles per hour packs far more energy density than the photon striking a solar panel of equal size. Today, we're going to explore 6 remarkable turbines that represent the cutting edge of residential and off-grid wind technology. Each one tackles the biggest obstacles in small-scale wind power head-on. We'll break them down by cost, performance, efficiency, and the innovative engineering that makes them perfect for real-world self-sufficient setups. Number 6. The T-Up Atlas. One of the greatest barriers to home wind power isn't the turbine itself, it's the tower. Local building codes and homeowners associations often view a 60-foot mast as an eyesore or outright zoning violation. This passive restriction keeps many homeowners trapped on the grid. But what if you didn't need a towering structure at all? What if you could change the geometry of how you capture the wind instead? Enter the T-Up Atlas, a vertical axis wind turbine specifically engineered to navigate strict zoning rules while delivering realistic costs for residential installations. In typical neighborhoods, houses, fences, and trees create highly turbulent, chaotic gusts. Traditional horizontal axis turbines waste enormous energy, constantly yawing their entire body to face shifting winds. The Atlas eliminates this problem entirely. Its aluminum scoops loop vertically around a central axis, creating a full 360-degree catchment area. It captures energy from any direction at once, thriving in the swirling, unpredictable air currents right around your rooftop. The true breakthrough lies in its structural physics, which delivers major cost savings. Mounting a traditional propeller on a building creates uneven forces, causing sway, humming, and vibrations that demand expensive structural reinforcements. The Atlas avoids all of that. Because it spins on a perfectly balanced vertical axis, all forces channel straight down through its center of gravity. There's no rhythmic buffeting, no low-frequency vibrations, and operation remains remarkably quiet. This allows it to bolt directly onto a standard roof beam or a simple ground pole. Financially, this system transforms the economics of home wind power. A heavy-duty entry-level Atlas core generator starts at a very accessible $900. Complete modular kits, including custom blade profiles and advanced charge controllers, typically range between $1,500 and $3,000. The integrated IoT generator can produce up to 10 kilowatts of raw potential power, managed through its built-in controller. It begins rotating at wind speeds as low as 9 miles per hour, and with specialized low wind blades that drops to just 7 miles per hour. Best of all, it requires zero extra land, stays nearly invisible to neighbors, and keeps installation costs minimal. The T-Up Atlas proves you don't need a 60-foot tower or a second mortgage to harness the sky, just smarter geometry. Number 5. The SD6 from SD Wind Energy. Most modern wind turbines are surprisingly fragile. They depend on complex sensors, electric motors for yaw control, and digital braking systems to survive storms. In off-grid living, complexity becomes the enemy of reliability. A single failed circuit board during a blizzard can leave you powerless. The SD6, designed in Scotland, stands as the complete opposite. A rugged 6-kilowatt powerhouse that prioritizes heavy-duty mechanical engineering over electronic automation. Instead of facing directly into the wind, the SD6 uses a downwind design where air passes the tower before reaching the blades. Natural wind forces naturally align the turbine like a heavy weather vane, eliminating any need for motorized tails or computer guidance. Its storm handling capability is pure engineering genius. While conventional turbines must brake and shut down in high winds, the SD6 stays operational thanks to its mechanical centrifugal delta rotor system. As winds intensify, the thermoplastic composite blades automatically twist and pitch backward, shedding excess force while continuing to generate power safely. This is serious equipment. The complete installed cost, including the turbine, a heavy-duty $9,800 hydraulic monopole tower, and professional concrete foundation, lands between $25,000 and $35,000. That's a significant investment, but the returns match the scale. With its massive 19-foot diameter rotor, the SD6 excels in areas with average winds around 12 miles per hour, producing an impressive 10,000 to 14,000 kilowatt hours per year. That's enough to completely offset the average American home's annual consumption of roughly 10,600 kilowatt hours. Built for 25-year durability with only annual inspections and bearing replacements every 5 to 7 years, the SD6 stands as a permanent, reliable sentinel that works hardest precisely when solar fails, during winter storms. Next, number 4, the Liam F1. Developed in 2014 by Dutch inventor Marinus Miramet, this turbine applies Archimedes' screw principles to overcome decades of challenges in small-scale wind. In open countryside, wind flows smoothly in lamina patterns that suit traditional propellers. But in suburban, urban or wooded areas, buildings and trees turn that flow into chaotic, rapidly shifting gusts. The Liam F1's conical spiral design handles incoming wind at angles up to 60 degrees off-axis without performance loss. The cone automatically yaws into the wind through pure physics, no sensors required. As air enters the spiral, it's redirected 90 degrees and slowed dramatically before exiting. This creates exceptional quiet operation, under 45 decibels, quieter than a refrigerator, compared to 55 to 65 decibels. For conventional 3-blade systems, the geometry also achieves remarkable efficiency, extracting up to 80% of the theoretical maximum energy available in the wind, known as the Betz limit. Priced at the premium end, the 1.5 kilowatt Liam F1 turbine costs around $3,200, with a fully installed system including controller, dump load, mounting hardware, and wiring falling between $5,000 and $7,000. Its ability to maintain performance in turbulent conditions makes it an outstanding choice for residential rooftops and challenging environments. Number 3, Flower Turbines. This innovation directly tackles the two biggest complaints about residential wind: noise and bird safety. Traditional horizontal axis turbines have blade tips moving 5 to 7 times the speed of the wind, creating high-pitched whooshing sounds. Flower turbines, developed in the Netherlands and United States, use a vertical axis design resembling elegant aerodynamic tulips. Their curved aluminum blades move at much lower tip-speed ratios, producing only a low-frequency hum easily masked by normal suburban sounds. You can hold a conversation standing right next to one. Beyond silence, these turbines defy conventional aerodynamics through the cluster effect. While traditional turbines create disruptive wakes that reduce neighbouring efficiency, flower turbines actually boost each other's performance by up to 20% when placed close together. The swirling air from one acts like a mechanical gear, accelerating its neighbours. This allows dense installations in small backyards or on flat commercial roofs. Their solid cylindrical silhouette when spinning also makes them highly visible to birds, virtually eliminating strike risks. Economically, they're designed as scalable modular units. Entry-level 3-foot models start around $1,400, ideal for small battery banks. Mid-range residential versions begin at $4,500, while larger commercial units reach $9,500. Their biggest advantage is an incredibly low cut-in speed of just 2 miles per hour. In urban areas where gentle breezes are common, these turbines generate consistent trickle power all day long. A cluster of 3 or 4 mid-sized units creates an interconnected microgrid that maximizes output from limited space. Number 2. Primus Wind Power's Air Series. Sometimes the greatest innovation comes from perfecting a proven design. Based in Colorado, Primus produces compact 400-watt micro-turbines. While 400 watts might seem small compared to utility-scale systems, it provides crucial baseline power for efficient off-grid homes, keeping refrigerators running, lights on, and communications active during long dark nights when solar is unavailable. Originally engineered for harsh marine environments, these turbines feature aircraft-grade aluminum bodies and carbon fiber reinforced composite blades designed to flex rather than break. The only moving part is the rotor itself. Revolutionary internal regulators eliminate the need for bulky external electronics. Simply run 2 copper wires from the turbine straight to your battery bank. At $1,200 to $1,500 per complete unit, the Air Series offers the ultimate low-cost entry into wind power. It starts spinning at 7 miles per hour and produces 30 to 35 kilowatt hours per month at a steady 12 miles per hour. Rugged, simple, and effective, it's perfect for cabins, tiny homes, or emergency backup systems. Number 1. The Icewind turbine. This Icelandic design tackles the opposite problem, environments where wind is overwhelmingly powerful. In places like Iceland, the Great Plains, or mountain ridges, extreme gusts destroy conventional turbines. The Icewind uses a sophisticated dual-blade system, an inner Savonia-style rotor for massive torque and ultra-low wind startup, combined with an outer Darius-style blade for high-speed efficiency. Constructed from marine-grade stainless steel, aircraft aluminum, and carbon fiber, it withstands winds up to 130 miles per hour. Its direct-drive generator sits safely at the base, fully sealed from the elements. No exposed gears, no high-mounted electronics. Models like the Freya series range from $3,200 to $4,500 and deliver 150 to 300 watts continuously. With a 25-year lifespan and virtually zero maintenance, it's the ultimate set-it-and-forget-it solution for extreme conditions. While society rushes to blanket rooftops with solar panels, many miss a fundamental truth. Wind possesses vastly higher kinetic energy density than solar. A single compact turbine can generate more energy during one dark winter storm than an entire residential solar array might produce in a week. Wind serves as the perfect complement to solar, especially during winter when winds peak as solar production drops. Adding even modest wind capacity can reduce battery storage needs by up to 40%. The first step towards smart integration is proper measurement. Spend less than $100 on a digital data logging anemometer and mount it at your planned installation height. Record data for 6 to 12 months to understand your site's true wind resource. If average speeds fall below 8 or 9 miles per hour, wind may not be primary. But strong winds transform your entire energy equation. Modern engineering has brought wind power to human scale. Whether using the T-Up Atlas to bypass zoning restrictions or deploying the indestructible SD6 for open landscapes, these systems turn regulations into design opportunities. Wind powered humanity's first great explorations and industries. That free fuel, 200 trillion kilowatts of kinetic energy moving through Earth's atmosphere, still flows over your roof every single day. If you believe the air above should be an asset instead of a nuisance, and you're ready to break free from utility dependence, the technology is finally here. For more ways to achieve true energy independence, check our video on Pico Hydro, an endless energy source you can build yourself for just $50.